So for the last part of this section of notes, what we're talking about is why do we need to have all of these rules? Why is it important that we know how to deal with exponents, okay? Well, the reason that it's important is because a lot of times you're going to deal with functions where there's a lot of different pieces, and if you've got ways to manipulate them and put them together, then your life is going to be a whole lot easier, especially when we get to the crazy math and cal, okay? So the guy who made this unit has a set of some things that you should keep in mind. Rewriting rationals, don't work with decimals, some things like that you're more than welcome to read through. But then he's got a section where there's difficult things to manipulate. So let's take a look at this one. They kind of work their way to more and more difficult. So this first one right here, I'm going to deal with each piece separately. So this exponent on the outside, I know I can distribute into all of those pieces because they are multiplied together. Okay, so this is going to be 2 squared, a squared, and I've got an exponent raised to a power, so this is b to the 6th. So all of these right here are this first term. This next term, I've got a coefficient, and I've got a square root. So the square root means that all of these are raised to the power over root. Well, this is a to the 1st, and it's the square root, so this is a to the 1/2. B to the power over root would be b to the 5/2. Okay, and then at that point, we can multiply our two things together, which means that we're going to take our common bases, so the a and the a, and we can add the exponent, the b and the b, and we can add the exponents. The 2 squared and the 5 are just numbers, so I can just add those together, or multiply them together, excuse me. 2 squared I know is 4, and 4 times 5 will give me 20. I've used these. I've got a squared, and I've got a to the 1/2. So if I add those two together, you don't ever want to give mixed numbers or decimals as exponents. So you don't want to tell me that that's 2 and 1/2 or 2.5. You definitely want to convert that. Well, I know that 2 1/2 is really 5/2. So this is a to the 5/2. Okay? Then we're going to do the same thing with b. Well, b, we need common denominators. So this is really 6 over 1, right? And 6 over 1, I need to make it be over 2. So that's 12 over 2. If I have 12 over 2 and 5 over 2, that's really 17 over 2. So this is b to the 17 over 2. So it should look something like that as your final answer. Okay? For part B, you'll notice I have all of this underneath the square root. So that means this root of 2 applies to every single exponent that you see. And even the one like on the 3 where there's that invisible 1 exponent that they leave off, it applies to that one as well. Okay, so the first thing I'm going to do is I'm going to rewrite this as 2u to the 5th. I'm just going to rewrite it as that exponent so that it's a little more clear to what's going on. And that's all to the 1/2 power. So this root becomes the 1/2 power. Okay, let's combine things inside before I apply the 1/2. That'll be the last thing. I don't want to make them fractions until I have to. So this 2u to the 5th is really 2 to the 5th, u to the 5th. This v to the -2, negative exponents really need to move to the other side of the fraction. So this v to the -2 is really going to move down. So that gives me a v squared in the denominator. The 3 will stay. U to the -1 means, again, it's on the wrong place, so I'll move that guy up. And v to the 3rd stays. And this is still all to the 1/2 power. Okay? Still combining things on the inside. 2 to the 5th I know is 32. That's one of those things that you should know. So this is 32. U to the 5th and u to the 1st is going to be u to the 6th. And this is 3 v to the 5th. And this is all still to the 1/2 power. In a perfect world, that 32 and the 3 would reduce. But unfortunately for us, math isn't always perfect. So the 32 and the 3 do not reduce in this case. So I'm going to go ahead and apply this exponent of the 1/2. So this is going to be the square root of 32, or you could leave it as 32 to the 1/2. And then u to the 6 to the 1/2. Remember, you multiply the exponents. 6 times 1/2 is 3. So this is u to the 3rd. 3 to the 1/2 is the square root of 3. And v to the 5th to the 1/2 is v to the 5/2. So you can write it this way, or we could have left those square roots as fractions. and this answer would have been perfectly acceptable too. Very honestly, this answer is probably the one that I would give, just because I don't like drawing the square root symbol. So either one of those two would be okay. On the AP test, they'll probably convert this to a root instead of leaving the coefficients as fractional exponents, but the V would have probably stayed that way. So, and then the last one is really funky. So let's kind of take this piece by piece. So we'll work with this guy all together. So again, I'm going to simplify everything that's inside of the parentheses first and then apply that -3. If you want to do it a different way, you'll still get the same answer as long as you follow the rules, okay? So let's kind of take this piece by piece. So on the inside, there's really not anything I can do with the 2, but the x to the third and the x to the 1/2 have the same base, so I can combine them. So x to the third and x to the 1/2, if I add those together, that'd be 3.5, which is really 7/2. So this is x to the 7/2. Y to the -2 needs to go to the other side of the fraction. Okay, this fourth root applies to everything that's inside right here. So this is going to be y to the power over root, so to the 3/4. And this is x to the power over root. So this is x to the 1/2 over 4, which is a little bit weird, but we can kind of deal with that. And then I'm going to do the same thing with this one. It's a cube root that affects all of those. So this term is going to be 4 to the 1/3, x to the 1/3. Y to the -6 means it's in the wrong place. But let me go ahead and just apply the 1/3 first. So this is y to the -2, okay? Because it's -6 over 3, so that's -2. Okay, so let's go back to this thing. I can put the x's together if they had common denominators. This denominator, 1/2 over 4, if I do, I'm going to do it up here so you can see. If I do 1/2 over 4, remember our rule for keep, change, flip? So we would keep the 1/2, that's really 4 over 1, change the division to multiplication, and flip the 1/4 over. So 1/2 over 4 is really 1/8. Okay, so this is the 1/8 power. So I'm going to cross that out and call this 1/8. So now I need this denominator to match up with the 8, so I've got to multiply by 4. So this is really 28/4. Nope, 28/8. There we go. Okay, so 28/8. So if I subtract these exponents, this is really now 27/8. Okay, so 27/8. So this is now 2x to the 27/8 over y squared and y to the 3/4 common denominators again. So this 2, I really needed to have a 4 in the denominator. So this is really 8/4. So 8/4 and 3/4 is 11/4. So this is y to the 11/4. And we're still dealing with that -3 exponent up there. Okay. So now I've still got this guy happening over here. I'm going to put that y in the denominator though. So we've got this. Okay, so now I'm going to apply this -3 exponent. The -3 on the exponent means the whole thing is going to flip over. So this is going to be, I'm going to flip it over and apply the 3 to the powers. So when I flip it over, this y is now going to be on the top. So this is y to the 33/4 over 2 to the 3rd, and x to the, well, if I multiply 27 times 3, 27 times 3, 1, 2, 6, 7, 8, it's 81. So this is x to the 81/8 power. Okay, I know it's gross, but we'll be okay. So 4 to the 1/3, x to the 1/3, y squared. So now we can combine this way, we can combine this way instead of up and down because we've already finished all of that. So this 4 to the 1/3 is going to stay on the top. X to the 1/3 and x to the 81/8, we need to put those together. And when I get common denominators and I combine, I end up with x to the 235 over 24. And it's in the denominator because that's larger. So when you get common denominators, you can subtract and you'll end up with that in the denominator. Okay? I'm going to keep my 2 to the 3rd. And then my y's, if I get common denominators, The y, so this is going to be, I need it to be a common denominator of 4. So this is, again, 8/4. I'm subtracting. So if I do 33 minus 8, 33 minus 8 is 25. So this is y to the 25/4. That's where I end up. And hopefully the assignment won't be too terrible, and hopefully that made some sense.